Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 1997 Nissan pickup truck. This little Nissan has a problem where it's running very poorly and stalling. Apparently it's running lean. So the first thing I want to do is get a scan tool on this car, and then I want to take it for a test drive. Let's hop in and go for a test drive. Okay, so I got the scan tool up. Now this car barely will idle. If I let it off and I let it idle on its own without helping it, it just dies on me. Runs really bad. Now we're lean, and we've got a control problem because we're not going rich lean, we're just staying lean. Even when I'm high idling, we're not changing. The long-term trim is okay, but short-term, I've got a large short-term correction. We're not warmed up yet, and my vacuum is pretty low as well. So right here I've got pretty low vacuum. We've got a code, and we've cleared the codes because we've got 4 monitors that haven't run, and we know they've been trying to fix it, so that's no surprise. I've got a P0100, which is the mass air sensor volume, and I'm not sure if this is from this code or they've been unplugging it. They told me that if they unplug the Maf sensor, the car runs okay. Now, that's not a good test, and I'm going to show you why. You got to be worried about unplugging stuff. But right now I think that might have come because they're unplugging it. But I want to come over here, and we want to go ahead and we want to get some other data, airflow. Then we want to come here. So I'm going to let it idle. Now the gram weight is 3.6, and we're still totally lean, and the car dies. Now this is a 2.4 engine, so if I'm hot unloaded idle, I should have somewhere about that gram weight. So this gram weight at idle should be somewhere above 2.6. 3 grams of air seems like it would be enough to me. That seems fine, but we're staying lean, just pegged. Like the air seems like I've got enough air to make the calculation, but we're still adding a lot of trim. So the short-term trim is 25%. Now guys, on an older car like this, you're not going to get much more than 25%. That's about railed my trim amount. So I'm adding as much trim as I can, and I'm still totally lean, but the air seems about right. Let's let it idle. Okay, if I let it idle, it's going to want to die. Now right there, we were at 2.2. When it died, that seems a little low, but before we were at 3. So let's just see what we get here. So let me just let it idle on its own. So we're at 4 grams, and we're still totally lean, and we're adding 25%. That tells me that we're pegging our trim out, and we still can't make up for why it's so lean. So I want to run another test now. We know we have low vacuum too. So let's come over here. I want to run trim, total trim, short plus long. We want to see what we've got, so we're going to just drive it here. Now we know they've cleared the codes, which means that they cleared these trims. And we'd have to drive the car for a while to get the trims back, because these have fire cycles to trim authority, and on these type of cars, the fire cycle to trim authority is going to be a lot. In other words, I got to have a lot of fire cycles to get much trim authority. So let's take a look at this data here and just see what we've got. Okay, the car's already dead. So we've got a lot of trim all the way up. So we have a problem, and it's not only at the bottom, it's not only at idle, but it's at light load and pretty heavy load. So the trims, and don't get confused on these, we just didn't run enough fire cycles and trim authority in that particular cell. We'd have to run it more in those cells to get them to trim. I think the whole scale has got trim because we have a problem all the way from idle all the way up. Now is what I want to do is I want to come over here. This is 2.4, so we're good there. I want to go ahead and I want to run a VE test on this. And the temp, everything's about right there. So the way we run this test is we want to just get rolling, and all you need to do is be in a low gear like first, and we want to run it clear through first gear. We want to take a look here. So we don't got to go real fast, you just need to make a pull in a low gear. The thing already died on me again, so let's get it running. Want to make a second pull. Okay, so we're way under reading the air, or we're over reading the air. Wow, that's not what I expected to be lean. Yeah, this thing won't even run, it just dies. Any type of idle and we're dead. So let's take a quick look at what we've got here. Okay, so the yellow trace here is what's actually being reported from the trim, and the red trace is what calculated air is. So we're saying we're pumping more air, but we have trims all the way up, and the trims are based off of the air. So we're overreading the air, which means we should be what? Rich, not lean, but we're lean. So this isn't an airside problem, this is a fuel delivery problem. On this car, I'm pretty sure we've got some kind of delivery issue to the car. Yeah, this car runs really, really bad. It's really, really lean. So one of the things we want to do is I want to go back to the shop and get my gas analyzer. I want to make sure that this thing is reporting right, that something isn't wrong with the oxygen sensor, because this could have an O2 problem and that might get us confused. I want to make sure we're really lean. The mass air is for surely reporting more air, not less air. So that should make us rich. I can't believe how fast it dies. I mean, it doesn't have any ability to run. And again, we can see right here where the yellow is higher than the red. Red is theoretical air, yellow is what's actually being reported. So we're actually overreading for the size of the motor. So, and that's also why these have negative numbers in here, and we're way overreading, which means we should be rich, not lean, if it's the air side. So this doesn't add up on this car. And I mean, we've got several computers over here on the seat. So I don't think that that's what's wrong with it. Right now, I think that this problem has something to do with the fuel delivery. That's what it would seem to me. But before I'll know that, I need a gas analyzer. So we've got positive trims and negative airflow. Those go in the opposite way. So I don't think this is an airflow problem. I think this is something to do with the fuel delivery. So the first thing we need to do is we just need to check the O2 sensors and make sure that they're right. Okay guys, I'm going to connect the gas analyzer. The first thing I want to do is I want to plug that exhaust just with it at idle. It immediately is building pressure against my hand. That means I don't have an exhaust leak. I want to make sure. Now we're going to go ahead and put the probe in. Now we'll go get our exhaust gas reading. Okay, so I've got my gas analyzer connected. I'm 60% too lean, a lambda of 1.6, 1.7, 70% too lean. The O2 says I'm lean with no switching, and my short-term trim is adding 17% right now. So we're trying to trim it, but it can't trim what the problem is. So I have a heavy trim, and my gram weight of air is 5 grams. There's a 2.4. We're not at idle, but it won't idle. So he's holding the idle up so it runs. So this is enough air to where we should have a good reading, but we're still extremely lean. 70% too lean. Something's wrong with the fuel delivery system. So what I need to do is get a scope on this thing and look at these injectors and probably a fuel pressure sensor so we can see what kind of pressure we have. Let me get that set up. Okay, I put a pressure transducer on this vehicle between the fuel filter and the rail. So now we can check the fuel pressure. I went over and I found the spec. Basically we should have 43 psi on this engine. So this is going to be my fuel pressure. This is in the injector so we can see the injection on time. Go ahead and start it. Okay, so we got 40 pounds, 41 pounds, and we can see we're going to be lean. So this isn't my problem because that's enough pressure to where I would be able to at least have the engine run. It's not going to be a lambda of 2 when I do this. I want to show you something else though. We want to go over here and we want to get some data. And now I want to measure this. This is the injection on time. So let's just see what we've got for on time. So I've got 4.57 milliseconds of on time. And we're revving it up and down. So let's get one of these over here where we're really not revving it and increasing that injector time. So here we're at 2.72 milliseconds of on time. Now what I want to do is I want to unplug the Maf sensor. The shop tells me when they unplug the Maf sensor, the car runs fine. So we're going to unplug it. And sure enough, we're coming down. It's not as lean. So now we're 15%, 16, 20% rich, not lean. And if I come over here, it shows I'm rich. And I don't have 25% trim going on. So this is right. This gas, the computer can control it and I can be rich. Now what I want to do is we basically add 2.72. I add 2.72 milliseconds. Let's get the new data. Now this is with that unplugged. So now we're not revving it. So it's going to come straight up now. So let me mark this out. So basically I have 5.29. That almost doubled the milliseconds of on time. Now guys, this is where people get in trouble. When you unplug things, the strategy from the computer changes. The reason that this is running so much better now, is because the injection on time increased. Because now it's not reading airflow, it went to a speed density system which is looking at vacuum. So my injector on time went up and I can be rich. Now what that tells me is if I have more injection on time, it can be right. That makes me think that something's wrong with the injectors. And the shop said that the shop that brought this vehicle into him changed these injectors. I think it has the wrong injectors. Because if I get just a little bit more calibrated on time, I can control my fuel. But the program doesn't know the injectors are wrong. And if the injectors are wrong, you've got to tell the program what your flow rate of those injectors is, or it's always going to be wrong. But what happens here is when I unplug a Maf sensor to prove the Maf is good or bad, you've made a drastic mistake because you just changed the calibration. Don't unplug things because it just confuses you. This car has had 2 mass air sensors put in it and a new throttle body because when they unplug it, it runs okay. But when you unplug it, you just went to another subsystem in the computer so it can run. Now it's running on the vacuum, not the airflow rate. What I think is wrong with this car is I think the injectors have the wrong orifice in them. So now what I want is I want to get the injectors that he took out of this car to start with. You know, when you've got 3 computers and you've got injectors and O2 sensors, a new mass air, a new throttle body, you get so many parts on the car, you start to get confused on what's really wrong with the car. But I think at this point right now, the injectors don't have the right flow rate. That's what this data is indicating to me. So I want the right injectors for the car, and then I want to go forward with this test. Okay, so we're going to get those injectors and then we'll take a look at this. So what I want to do now, now every time that injector opened, we have a drop. You see how it drops? So a fuel pump's job is to put enough volume into the rail so it makes pressure. The injector drops volume, decreasing pressure. So each one of these shows that I open the injector up. Now they're all even, we can see that. So if I take a cursor, I can see that they're all even. So my drops are the same. So I am giving fuel. So fuel is being delivered, so I'm okay there. Okay guys, I want to show you how I know the current to these injectors is okay. So let's stop this. I want to come in with my zoom window. We want to zoom in on these. Now the first thing you might look at is you might think that that's not a good waveform. It's really different. But on these Nissans, that's a good waveform. But if you look at the tower and you look at how wide it is, it tells me I had current. The next place I want to look at for current is I want to look down here at the bottoms. So if we look at the very bottom, that's the current. Do you see how I came up and I got the pintle opening? You see how nice the ramp that is, and you see the pintle bump right there? And if I want to just make that a little smoother, I can do that. See that curve? Well, that'll match a current clamp. So that's telling me that I have the right amount of current flowing in these injectors. The next thing I've got is just to make sure that I don't got a voltage drop. We can see that that's my power and I got no drops in it. But by looking at this injector voltage waveform, by looking at how big this tower is right here, how wide it is, and looking at the bottom here, I can tell a whole lot about this injector. Now that's a good, that'll match an amp clamp right on the money, because the same properties that give you the current with an amp clamp are making the induction pattern in the bottom of this waveform. So that is, I have good current. So these injectors don't have a problem with current. So I now know that the current of these injectors is okay. Okay guys, this is such an important idea that I really need to give you a further demonstration to make sure that everyone understands this. That when you're dealing with an inductor, a coil, that you can tell what the current is by looking at the voltage displayed. So a conductor is a wire, and when current goes through this wire, when the electron rips free of the atom starts in a rotation. Every time an electron is freed from that atom, the atoms start to rotate. When I get enough atoms all rotating in the same direction, I have a magnetic field. So when I get a few billion of these atoms all rotating the same orbital direction, it makes what's referred to as a dipole, and dipoles are magnets. Now, that means that all of the current that flows through this wire is become a magnetic field. That's why we can put an amp clamp around a wire and we can read the current flowing through it, because the current is producing a magnetic energy. An inductor is where I take a wire and I turn wraps, winds. For every wrap or wind I turn, I have an amplification of 1. So if I made 10 winds, I would amplify the magnetic field by 10 times. So when we look at things like coils for an injector or ignition coils or VCT control coils, they'll have many, many wraps. Now, as that current goes through this winding, it makes a magnetic field. When I have a wrap, that magnetic field now is made and it goes out across the winding. It starts to cross the winding. Now, one of the laws is when the wire or conductor is moved in and out of a magnetic field, or the magnetic field is moved in and away from it, I'll have induction or I'll make voltage in the wire. Now that voltage is going to oppose the current that's flowing through the wire. This opposition to this is referred to as counter voltage, and we can see this at the bottom of the injector waveform. Let me demonstrate. This is an injector waveform. This is open circuit. There's no current flowing. We turn the injector on with a driver. It's on and it turns off here. We get the flyback voltage, and then we get the pintle bump that shows it open. We'll go over this each one. What I first want to show is I want to show the bottom of this waveform. So what we're going to do is we're going to come up and change our voltage setting here so we can zoom in a little bit. Okay, the white trace, this is an amp clamp. The yellow trace is the bottom of that voltage waveform. I'm going to change this. I'm going to go down to 20 volts to get a better scale. Now, this is the voltage waveform, and this is the amperage waveform from an amp clamp. Do you see how they mirror each other? This is a great technique, guys. Isn't that cool? That means I can look at a voltage waveform and have some indication of how much current is flowing through the circuit. Do you see right here where I can see the pintle opened? Well, when the pintle is made of a ferrous material, it's magnetic in nature, like iron. When it is pulled up by the magnetism, it moves through the magnetic field, and the magnetic field pulls back in through the winding, and that movement of, or flexing of the flux, the magnetic flux, induces voltage, and that voltage gives you less current. So this is less current here, but this is mirrored here. If we go back up here, this bump over here is being caused by the same thing. The pintle is going to move back down. I don't have enough magnetic energy to hold it up against the mechanical force of the spring, so the pintle, once the magnetic energy falls or it's shut off, the pintle is going to be forced back onto its seat by a spring. Now, as that pintle moves through the magnetic field, it has the flux of the magnetic field is pulled towards the pintle, and that gives me an induction. Now here we can see a voltage increase, and that shows that the injector opened. So if I'm working on a tranny, I look for these pintle bumps right here, and it tells me the valve can open. Or an injector, that tells me that the valve opens. Now, not all injectors will have these bumps, but this particular injector that we're looking at right now does. So let's go back down and look at the bottom of this again. So here we can clearly see that we have this magnetic field. Now I'm going to put in resistance. So I'm going to put 10 ohms of resistance. You can watch the current fall. See the current fall? That's 10 ohms on a 15 ohm injector circuit. Now the thing about this is when you have resistance, voltage goes up because voltage is present to push electrons through resistance. So if I have resistance, I need more voltage present. That's what gives me this voltage drop. This is the bottom of that injector waveform, and I can still see where the pintle moved. But now the pintle moved over, it has a latent opening. See, it's right here. Now it moved over here. So because I have resistance, I have less current, so it takes longer to overcome the mechanical force of the spring. But when you're looking at the bottom of the waveform, this point right here, if you have a MOSFET you will have 0.2, 0.3 volts from the bottom here. That's what you're going to have. So we're going to turn this off. We don't have resistance, and we're expecting somewhere about 0.1 to 0.3 volts. That's the resistance of the actual driver. If you have a transistor, you're going to come up and you're going to be up towards 0.7 of a volt. You'll be up in here that it'll drop. So just be aware that if your voltage is raised just by 0.7, it's just the style driver you have. If you have a MOSFET, it'll be lower. If you have a transistor, it'll be higher. But when you have any real resistance in the circuit, it's going to be way high. And once I hit my saturation, this curve right here, the field is still building. When the field stops motion, it stops moving, I hit saturation and then I level out. This is referred to as the saturation of a coil. It's all the current has gone through it, and now I'm fully saturated. Now if you look at the saturation level, you're at 5.5 volts. That shows that you have resistance in the circuit. Now I can also, we can put one of these in the power. The red is the power, so let's do this. I'm going to put one in the power. Same thing. That's 10 ohms. I want a little bit more resolution, so let's come down here. Do you see how this is just being inverted? What we did see on the bottom is now in the power, because the same resistance is causing these effects. It's just one's on a power and one's on a ground. I'm going to put the ground one in. Here you can see the power side and the ground side, and you can see how they're mirroring each other. These are all just attributes of how an inductor is going to work. But always be aware that I can see voltage drops in the power, and notice the power does not show a voltage drop until I turn on, because you cannot have a voltage drop until current is flowing. This is the circuit's off state. This is when I turned it on, so you got to turn it on to see a voltage drop. That's going to go for injectors or ignition coils, anything that's being turned on and off. You cannot see a resistance in that circuit until current is flowing. In this case, I have resistance 10 ohms is in the ground and in the power right now. And I want to show you something else that you're going to want to check. Another really important point. We want to change our trigger to rising. We want a little more time. So now is what I want to show you. Look at this tower. How wide the tower is gives me a real good indication of how much current it is. Do you see how narrow it is? This is the clipping diode, and you can see how you can't even see it because it's just goes down in a point. That tells me I don't have much current. These are really close together. I'm going to take out these drops now. Do you see how wide that got? And you see how we got the clipping diode? This is a Zener diode, and it's clipping at about 65 volts. The clipping diode is used to control how fast the pintle can go down. If it goes down too fast, it'll beat the seat out. So a diode allows the current to flow around and around the circuit. If I had a regular diode, it would drop all the way to 12 volts, allowing the current to cycle, and I'd have my slowest closing time. If I want to make a circuit to match the spring, I pick a 6585. This clipping diode is what it's going to do, is it's going to allow the current to loop until 65 volts, and then it won't loop. That allows the pintle to have a slower decay rate, so it doesn't just fall and the spring force doesn't beat the seat out. It's just like a shock absorber. I want it to fall very slowly, a controlled method. The way the engineers control this is with a Zener diode, and the clipping diode is set and it's matched to the spring, the mechanical spring in the injector. So this clipping diode is very important that it's right for the injector so they don't beat out and they don't bounce and give you extra fuel. When we come down, we can see the bump right here, and that bump is, well, the magnetic field fell, the intensity, and now that pintle fell through the magnetic field and gave me induction or a positive kick, and that's that bump right there. When I'm looking to see if an injector is sticking, get it in a triggered mode like this and watch this. And if the bump starts bouncing back and forth, if it's moving around, it's not steady, that shows me that it's sticking. It's not coming through at the same time each time, but something's wrong with the injector. And that can give me a fueling problem to where I could overfuel the car because it's not falling in the same place. So this tower becomes a very important place to look to see how much current I have in the circuit. And the other place that I always want to look to see my current, and let me show you the tower again. See how narrow it gets? See how wide it is? When they get really narrow, it's cutting the current down. That's telling me I don't have enough current in there. So if you have a question, always put a current clamp on it and measure it. But a lot of times, I'm just trying to get through the diagnosis of the car. I'm trying to make really quick assessments using my scope. And this is a technique I use every day. I use this on all kinds of circuits on automotive. And it's very successful for me. So I want to make sure I explain this to you so I can help you be more successful using this type of technology. This is a great trick. And again, we're going to take a look at we're going to go from 500 volts to 20 volts. And again, what that does is gives me more resolution. That's why it cleared the bottom of the waveform up. Now the scope I'm using has a whole lot of digital bits for the vertical resolution. It's a 16-bit processor. So that means I have 65,000 points of resolution. So if your scope doesn't quite look like this, look for the curve and it will still work for you. But just be aware, it takes a lot of bits to make these little tiny voltages this clear. So don't be discouraged if you're using your scope and it doesn't give you a really good waveform. It will work for you. What you're looking for is the overall curve. And if you come over and we look at this, let's come over here, we'll get some data. So now you're going to just take and you're going to zoom in here and you're looking at the bottoms and you're looking for one to maybe be high. Let me show you. See how you can see the bottom go up and down? Well, if you're watching this on your scope, what you're interested in is to see if those bottoms came up. And if you don't have a round curve, if you don't have this kind of a curve where it's rounding, this is showing the magnetic field is being built. If it's just flat, either you have very little current, flat and low is very little current. High and flat might be a shorted injector. And the tower from a shorted injector will also be affected. You won't have a wide tower because there's no windings because they're shorted. So you'll have like a really small tower that's real narrow. That gives you the idea the tower is shorted or the injector winding is shorted. You'll have really high current, but you can see a shorted injector in the voltage waveform very easily. Guys, I hope this helps. Okay guys, now that we know the injector has current, that's all right. I need to do one more thing. We know that we have pressure, but I don't know that the fuel's not aerated and I don't know that the fuel doesn't have alcohol in it. Go ahead and shut it off. So let's go ahead and check that real quick. Okay guys, so what I've done is I put a clear hose on the outlet from the fuel filter so we can check aeration and volume. Go ahead and hit the key. So I have really good flow and we can see in the clear hose there's no aeration at all. So there's not any air, so we're good there. And we had good flow, so the volume is good. You know the volume is good because you have pressure. What you don't know is you could have aeration or bubbles and the compressed air will still build pressure, but you don't have pure liquid going into the engine. And that can give you a problem. So what I want to do now is I want to check and make sure that this is a good fuel stock. So we're going to check the API of the fuel. That's to make sure there's no alcohol in this fuel. Okay, so that's good gasoline. There's no alcohol in it. The API is good, and it's a heavyweight fuel because it's summer here. So the fuel is good, the fuel stock is good, the volume is good, and there's no aeration. So now what the shop will do is he's going to get the injectors, the ones that came out of this to start with, and we're going to put those back in it so I can just see what's going to happen. I mean, when people start swapping this many parts, I really want to put back the original injectors just to make sure we don't get burned that way. So when he gets those injectors put in, we'll come back and we'll film the result of those injectors. Okay guys, we're back over at the shop on this little Nissan. He got the old injectors from the other shop and he's put them in. We still have the same problem. We're extremely lean, 25% trim. We have a good airflow rate at 7.8. We're having to feather it to keep it running because it's 30 to 70% too lean. So we have a lot of 8C. The CO2 is low and the CO is really low. Now these numbers are with high O2. This is really a lean mixture. And this is telling me it's lean. Now maybe these injectors made it a little bit better. It's not quite at 70, but it's still got a problem. That didn't fix anything. The car's still not right. So now, what do we know? We know that we're not getting the fuel into the engine. The fuel pressure's there. We have good volume. The fuel's good. And now we have another set of injectors, and the injector on time was good. So that tells me, how does the fuel, you gotta stop and you gotta start to think about this stuff now. Now, what are we gonna test? Well, the thing I wanna test is the fuel pressure regulator. I've seen them fail. And all the fuel just goes to the return in the tank and it doesn't go into the fuel rail. So the line where we're testing has 43 pounds, but there's not 43 pounds in the actual fuel rail. The regulators go bad, and I've seen a similar problem to this. So what I want to do is I want to take the return line off of the regulator and see how much fuel is coming out of it. If we've got a really high fuel flow, well then we know the regulator is just bypassing all the fuel. That way the fuel can push against the regulator so I have the right 43 pounds, but it's not putting it into the rail, it's putting it back to the tank. So let's go, let me get that test set up and then let's see how much fuel is coming out of that regulator. Okay guys, it's been a long time since I've checked the return rate from one of these cars because these have all gone away. But when 20 years ago, the rule of thumb I would use is I wanted it to have a quart in 30 seconds. If it's more than a quart in 30 seconds, we're going to have an issue. So basically a quart in 30 seconds is my rule of thumb. So let's go ahead and test this. Okay, I've pulled the return line off of the regulator. Now this would be going back, would be the flow that would be going back to the fuel tank. Go ahead and just hit the key. Look at that, that's as much fuel as what would be coming out of the filter. Go ahead and start it. All the fuel is going back to the tank. Nothing's going into the rail. Do you see that? Kill it. Okay guys, the fuel pressure regulator is bad. That's what's wrong with this little Nissan. All the fuel is just bypassing to the tank. So wow, that's a crazy car. I haven't had one of these and it's been 10 or 15 years ago since I saw this problem. But this is a really tough problem when you get one. You can also find this problem with an amp clamp watching the fuel pump speed. When you're under full load, the engine will start to use a little more fuel and the speed of the pump will slightly increase. But this is just old school. It's really simple. It's a really basic test. So that's the story. I mean, you could see how much fuel is going back to the tank. It's basically all being returned. So the fuel pressure in the rail isn't the line pressure. So we have low fuel pressure. And remember, the fuel flow across the injector is the fuel pressure against the orifice size. That's what sets up the fuel flow rate. So if I've got a restriction before the rail and there's no pressure, way to check pressure in the fuel rail, this car doesn't have that. So this is the next best test I could think of. But now I know the regulator is bad for sure. There's no way all the fuel is returning. Okay, so he'll get a regulator and get it on this car, and this car is going to be ready to return to the customer. What I want you to take away from this car is always stay with a very logical approach. One test drives the next test. You will always fix the car. This car has got a lot of parts installed on it, and it still has the problem. And all we got to do is look at the data and let the data drive us. And if you do that and you have a scope and a gas analyzer, you too will be successful diagnosing vehicles in your base. Okay guys, we're back over at the Nissan. He ordered the fuel pressure regulator. It finally has come in. He's got it installed on the car, and we can see our lambda is 1.2, 2% lean. We can see we have good fuel control. The scope is on the O2. The injector is doing correctly. Let's take a look at a couple of things. Right here we have 5.3 grams of air, about the same weight of air as we had before. We have a lot of trim being added right now to correct that fuel though. So the car still has some problem, but let me go over this. Okay, so now, let's see what the injection on time is. Okay, so basically we have 2.95 milliseconds of on time. So guys, the air weight's the same, the fuel pressure's the same. Fuel pressure is 35 pounds right now, 36 pounds. So the fuel pressure is the same, the air weight's the same, the injection on time is actually less, but we have a lambda of 1. That shows me that now the fuel pressure in the rail is correct, so the flow out the injectors is very close to being right. Now the throttle body was replaced on this car. Now they need to still set up the TPS, and they need to set the idle control and set the timing, and then learn it to the computer, and then we need to look at trims and all the rest of this. We know the idle isn't quite right. Now we can also come back over here. I want to hold the throttle up. Before, when we went under any kind of load, it was just totally lean. Now we can see off idle, we have good control, and our lambda is good. Conversion factor 14.4% CO2, low CO, low oxygen. So this car is doing much, much better. It's not 70 or 90% too lean. It's just a little bit lean. Now the trim has a big trim. But before we get caught up in doing any of that, he's going to have to set up this new throttle body so the computer knows where it is for this car. So the shop will take over from here. They'll finish the car up and deliver it to the customer. The problem I was hired to fix is fixed. It's not 90% or 70% too lean. The car idles. Before we had to have someone in there gunning it the whole time. Now the car is just sitting here idling. So we have good control and we have a good lambda. The only thing that was changed is the fuel pressure regulator. That's it. So the regulator fixed the problem because now the rail pressure is the correct amount of pressure. So the flow rate out the injector is right. They just need to set this throttle body up in this car. Once they get it all fixed and the trim is right, they'll be able to deliver this to their customer. Thank you guys for watching. Okay guys, this Nissan, isn't this a cool problem? Come on, this car's just cool. I mean, problems like this is why I work every day on these cars. Because no matter how hard or weird the problem is, if you follow a logical thought process, you can fix any car that comes into your bay. Now, I got a lot of guys who say, oh, I don't need a gas analyzer. Don't need one. I'm not in an emission state. But guys, a gas analyzer was made in the 50s before anyone was worried about air quality. They built it because it's a great diagnostic tool. It's a tool that can tell me how lean I am or how rich I am, so I have a better understanding of what I got to do to fix the car. Gas analyzers and scopes are great. They really help you fix cars, guys. This is just a really great little car. I hope you guys enjoyed this as much as I enjoyed working on this car. Have a great day.